delay analysis methodologies based on SCL delay and disruption protocol. So edition 2, 2017 of SCL delay and disruption protocol gives 6 methodologies to do delay analysis. So we are going to discuss in this video how we can choose these methodologies based on what are the criteria. So the first and foremost delay analysis methodologies is impacted as planned, which is a very basic methodology. It is a prospective methodology. So what is the analysis type? Is cause and effect. It is an cause and effect type of analysis that you are going to insert the delay events into the baseline, and the software will try the end date or a change in the project delivery date. So that will be considered as the new extension of time for the project. So critical path here is determined prospectively. Usually it is software driven, and we can also make it without software driven, but it's more reliable on softwares. How the delay impact is determined, that is also determined prospectively, because the intention of this delay analysis is to find the end date, because both the parties, contractor and the employer, will not be aware of when this project is going to end. So that is the purpose of this analysis. So what are the data required? So the mandatory data is the baseline. You should have a baseline, and that should be approved between the contractor and the employer to avoid any ambiguities. And the second data is the selection of delay events to be modeled. What is the phase of the application? It is usually prospective. That is when the project is ongoing. See, this can be usually entertained at the very starting of the project, like 20% or maximum 30%. After that, if we use impacted as planned, if we have other data, it is in wrong approach. If we don't have other data for small projects, this can be used. So what is the complexity? Complexity is medium. It's not high. Accuracy is also moderate, because it is a completely theoretical prospection of the analysis. Software requirements, yes, we need software requirements. Usually Primavera and MSP are used, and there are also other softwares in the market which can be used for the scheduling purposes. Expertise required is also moderate. For example, construction projects, like you are modeling the prospective delay analysis before the project completion. That's what the phase we can use, just for understanding. The second methodology is time impact analysis. This is also a cause and effect analysis. So there is a cause, that is a delay, and what is the impact of the delay? So that is how time impact analysis works. Time impact analysis, the critical path is determined contemporaneously, because we have factual evidences, and that can be used as the requirement for critical path. But mostly this is also based on the softwares, and the delay impact is also determined prospectively, because this is also a prospective kind of analysis. So what are the data required? Or you need a logic linked baseline, that is mandatory requirement. And second is there should be updated programs or progress informations to update the baseline. So these are the data that are used as contemporaneous records, because that will affect the change in critical path. The critical path will be dynamic in time impact analysis when it is window sliced. Next is the which phase of the project it can be used is the duration during the project. That is, you can use it right from the starting of the project to 80%. So that is the range that where you can use. Complexity is high, because you have to slice down into more windows, and you have to use more updated schedules. And the updated schedules has to be monitored, or it has to be shared between both the parties, because you cannot bring a new updated schedule and say that this is an updated schedule and we're using it. And accuracy is also high because we can slice down the delays and see what exactly happened for a particular delay for a particular period of time. What was the impact? Software requirements, of course, we have to software is mandatorily required, and expertise is high. For example, if it is an infrastructure upgrade project, so the updating schedules will give you more clarity on the delays already occurred and the delays that are ongoing and delays that are expected, if any. So that will have the consequence of all the three. The third delay analysis methodology is time slice window analysis. This is an window analysis, and the analysis type is effect and cause. Even though we are breaking down the project, we should know that the delay has already happened. The intention of the analysis is to find who is responsible for the delay, because the delay has already occurred. So you know what is the delay in the project or delay in the window. So your motive is to identify who made the delay. So this is a retrospective analysis, usually done at 80% or above 80% of the completion. And for this also you need a logic linked baseline. That is very mandatory and it has to be approved by both the parties. Okay, now coming to the program updates, these also require updated programs, progress information, similar to TAA. So the phase of the project is during the project. Even though it's during the project, it's usually appreciated if it is more than 50% of the project. And complexity is also high, accuracy is also high, software requirements is heavily dependent on the software requirements, and expertise is very high. For example, in a large-scale development projects, you are assessing a delay using the periodic updates. If it is very complex project and the delays are from multiple stakeholders and you want to analyze them, then this is the right approach. And coming to the most common methodology, as planned versus as built analysis. See, this is why most common methodology is disputes occur at the end of the project. And when you wait for the project to end and you want to go for a delay claim, then your only option is an 𝐴𝒂𝒄 analysis. It is an effect and cause analysis because you have an as-built data. It means that the project has completed already and you have all the contemporaneous records. So the critical path is determined retrospectively. See, in first three methodologies, softwares will give you a good support in tracing the critical path. But in 𝐴𝒂𝒄, you have to have a high expertise as a delay expert to trace the critical path. So that is a very critical step in 𝐴𝒂𝒄 analysis. And how you determine the delay impact? It is, of course, retrospectively. Data required is a baseline program. And you don't need to have updated programs, that is software-driven programs, but you should have as-built data. Even though you don't have an as-built program, you can use an as-built data to do this analysis. Phase of application is completely retrospective, that you can use only after the completion of the project. Complexity is very medium. Accuracy is also moderate. But this is the most common used methodologies in arbitrations and most trusted methodology in arbitrations. Software requirements usually they don't much depend on the softwares. Ordinary project management softwares can be used. You don't need any program management softwares. Even Excel is more than enough to an 𝐴𝒂𝒄 analysis if you have the expertise in tracing the critical path. So expertise is moderate. And for example, if you are renovating a building, okay, so you have to, the building is being completed and you want to compare the delay only in the renovation part. in comparing with the original, what was the original plan, and what was the original available building, and what are the delays that has been occurred, and who is responsible for the delays. So main attitude of the retrospective delay analysis is to fix the attributability. So attributability is nothing but the responsibility of the delay, so that that party is responsible for the time and the cost compensations. So next is the fifth methodology, which is the longest path analysis. They used to call it the retrospective longest path analysis. So as the name indicates that this is an effect and cause methodology, and it is critical path is determined retrospectively, delay impact is determined retrospectively, and the data required is the baseline program and as-built program. You need a program. You can't do with the data. So the phase of application is retrospective, completion after completion of the project. Complexity is medium because we don't have much data. We have only 2 inputs and we can easily perform this. See, the medium complexity doesn't mean that the product output will have less accuracy. You should be not just an accurate answer is required. You need a factual answer empirically to convince the parties to say that there is a delay from other parties. Accuracy is high for longest path analysis, but it is very, very, very rare because projects with an as-built program is very less. To identify a project with an as-built program is very less in the market. The accuracy is always high. Software requirements, you can use any project management softwares. Simple softwares is enough. Expertise required is moderate. For example, if you are doing a software development, not just in contracts management or construction management, if you are working in IT programs and we have to identify the longest delay impact in the project delivery. So for that, you can use this kind of analysis because IT projects used to maintain the as-built programs. The final one is the collapsed as-built program, and this is the only program, this is the only analysis that can be done without a baseline program. So that is the specialty of the collapsed as-built. So collapsed as-built is also in cause and effect. It means that delay impact is analyzed retrospectively, critical path is determined retrospectively. The data required is logic link as-built program. We don't need any baseline program. And a selection of delay events model. See, this is nothing but an exact opposite of an IAP. In impact as-planned, you have a baseline, you have model delay analysis. This is collapse as-built where you have an as-built program and the model delay events. Here you will remove the model delay events from the as-built analysis to see what the original date each stakeholder could have been achieved without delays. So this analysis will be done 2 times for the contractor and for the employer separately, and might be for the third party delays or more for separately. So you will remove the delays, and without contractor delays and force majeure delays, what the employer delays could have impacted, and that we repeat that for other 2 also. So this is also a very rare kind of analysis in the market because it's very rare to get an as-built program and not to have a baseline program. The phase of application is retrospectively because when you have an as-built program, it means that the project has been completed already. Complexity is very high because the people who know this analysis itself will be very less in the market. Accuracy is also very high. And software requirements, yes, you need advanced project management softwares like MSP or P6 mandatory to do this analysis. Expertise required is also very high. And for example, if you are doing a historical analysis assessing the specific impact of a specific event after a project completion, that you can remove the specific delay models and you can simulate what would have been the project delay or what would have been the project's behavior if this delay has not occurred. So that is the beauty of this analysis. So this is a very basic understanding you should have before entering into an daily analysis. Hope this video will help you on that. Thank you.